For stepping down the AC voltage, we use transformer. But for stepping down the DC voltage, what should we use? The answer is very simple and basic, and it is used in almost every electronic devices. The answer is voltage regulator. In this video, we are going to see how the voltage regulator, buck converter and boost converter actually works. Before talking about buck and boost converter, we need to understand what is the voltage regulation actually means. Imagine the water pressure regulator on your home. No matter one tap is on or 10 taps are on, the pressure on the regulator remains the same. The same concept applies here. The main principle of the voltage regulator is the output voltage remains constant, no matter how much amount of the input voltage changes and how much amount of the current draw changes. But why do we need this? Because our components are very picky. Our microprocessor needs exactly 3.3 volt, our LED needs exactly 5 volts, and our motor needs exactly 12 volts. But for this constant amount of voltage, we can't rely on the power sources because the voltage of the battery drops as the battery discharges, and the mains voltage fluctuates throughout the day. If we give too much amount of the voltage to the components, they will burn out. And if we give too little amount of the voltage to the component, they don't even work properly. That's why we need voltage regulators. Basically, there are two types of voltage regulators. First is linear regulator, and second one is switch regulator. Linear regulator is the oldest regulator, and it is with us for around decades, and it is used in almost everywhere. The working principle of the linear regulator is as imagine a transistor act as a variable resistor. As the resistance increases, the voltage drop across it also increases. Thus, the less amount of voltage reaches to the circuit. The circuit constantly monitors the output voltage. If the output voltage is high, the resistance increases, and if the output voltage is low, the resistance decreases. But here is the main problem, and it is very crucial to understand why the buck and boost converter actually exist. Suppose we have 12 volts of input voltage and we want 5 volts of output voltage, and the current drawn is 1 ampere. But where is the excessive amount of that 7 volt goes? In the linear regulator, it has to go in somewhere. It goes in the transistor, in the amount of heat. Let us calculate the amount of heat which is wasting. Volt is our input voltage, 5 volt is our output voltage, and 1 ampere is the current. Therefore, the 7 watt of pure heat is wasting. So here is the main problem regarding to the linear regulator. If we are going to calculate the percentage of the energy which is wasting, we can say that it is 7 by 12. That is almost 58% of energy we are wasting, which is more than half of the energy. It means that the efficiency of the linear regulator is 42%. That's why we need to work with the buck converter and boost converters. Now we will see another type of voltage regulator, that is buck converter. Buck converter steps down the voltage by stepping up the current. The main difference between the buck converter and the voltage regulator is instead of wasting the energy in the form of heat, the buck converter stores the energy and releases it with the help of the three components, that are inductor, capacitor and diode. Let me draw the circuit of the buck converter. There are two phases of it. In the first phase, the switch will turn on. By turning on the switch, the current will flow from the source to the inductor. In the inductor, the current will be stored in the form of magnetic field. It means that in the circuit, the current will increase slowly. In this phase, the diode will be off and the capacitor will be discharged. In the phase 2, the switch will be off. Hence, no current is flowing from the input. Now the Lenz's law comes in the picture. Due to the Lenz's law, the inductor refuses the current to drop in the circuit. It is like the momentum in physics. The inductor wants the current to flow in the circuit. So what does it do? It forces the diode to conduct. So now the current is flowing from the inductor through the diode, and in this phase the capacitor charges up, and the inductor stores the energy stored in the inductor, means the current stored in the inductor decreases gradually. This switching happens incredibly fast, hence we get a filtered output voltage. Now here is a key equation, that is the output voltage is equal to input voltage times the duty cycle. The duty cycle means the percentage by which the switch is on. Hence, for example, our input voltage is 5 volt. Sorry, our input voltage is 12 volt and the output voltage is 5 volt. So let's calculate the duty cycle. It means that 48% of time the switch is on and 52% of time the switch is off. Now by the law of conservation of energy, the input power must equal to output power. So by that relation, the input power is equal to output power. Therefore, V input into I input equals to V output into I output. Suppose, for example, our input voltage is 12 volt, input current is 1 ampere, and output voltage is 5 volt. So what is the output current? So we put the values here. See, the input current was 1 ampere and the output current is 2.4 ampere. Means the current is more than double. Means as the current increases, the voltage also decreases. So we can see that current has increased and voltage is also decreased. The advantages of buck converters are, the efficiency of buck converter is 85 to 95%. And it can also operate high amount of current, and it also generate less amount of heat. The disadvantage is it can only step down the voltage. It never step up the voltage, and it also has the very complex circuit, and it can generate electromagnetic interference if it is not filtered properly. So here is all thing about the buck converter. Now we'll talk about the boost converter. The boost converter is exactly opposite of the buck converter. In the buck converter, the voltage decreases by increasing the current, but in the boost converter, the voltage will increase by decreasing the current. The components are used in the boost converter are exactly as used in the buck converter, but in different arrangements. The arrangement is like in the phase 1, when the switch is on, the voltage is going from the input to the inductor. In the inductor, the current is storing in the form of electromagnetic field. And right now the diode is in reverse bias condition, therefore the diode is off, no current is flowing from the diode. Meanwhile, the capacitor supplies its independent voltage to the load by using the energy from the previous cycle. In the phase 2, the switch is off, means the current is not flowing from the supply, but the inductor still trying to maintain the flow of current. It seems that it is adding the input voltage and the voltage coming from its own together. Now the diode is turned on and it is now in forward bias mode. The current is flowing from the supply and from the inductor through the diode to the output. It seems that the voltage is equal to the output voltage is equal to input voltage and the voltage coming from the inductor. It means that we are using the inductor to stepping up the voltage. Let's calculate the duty cycle. The formula for duty cycle is V output equal to V input upon 1 minus T. Let's take V output as 12 volt and V input as 5 volt. Therefore, the switch is turned on 58% of time. By the law of conservation of energy, we can calculate the input current. Suppose the output voltage is 12 volt, output current is 1 ampere, input voltage is 5 volt, and let's calculate the input current. Therefore, 5 into 22. It means that we must supply the more amount of current to gain the more amount of output voltage. The advantages of boost converter are as follows. The efficiency of boost converter is 85 to 95%. It can also step up the voltage from low sources. It is suitable for the battery power devices. The disadvantages are as follows. The disadvantages are it can only step up the voltage, it can never step down the voltage. The circuit is very complex, and sometimes it also generates the electromagnetic interference due to unfiltered signals. We have seen in this video. Firstly, we have seen what is the voltage regulation. The voltage regulation is the process of keeping the output voltage constant by changing the input voltage. Then we have seen the types of voltage regulator. First is linear regulator. The efficiency of linear regulator is 48%, and in the linear regulator, it wastes so much of energy in the form of heat. To solve this problem, we have used buck converter to step down the voltage. Buck converter only step down the voltage, it can never step up the voltage, and the circuit of buck converter is very complex as compared to linear regulator. Then we have used boost converter. Boost converter is used for stepping up the voltage by decreasing the current. The circuit of the boost converter is also very complex, and the main problem with these two converters are the electromagnetic interference by unfiltered signals. So thank you for watching this video.